In this video I'll show you how to use lavaan and R to assess the discriminant validity of a measure. Discriminant validity is about whether a construct does really measure something different than other established constructs. So it's about a comparison of at least two measurement models. We need lavaan and we need SEM tools. First we have to run a CFA with at least two constructs we want to compare to each other, because we want to assess the correlation between those two measures on the construct level. Here's a simple CFA with two factors. It's based on an inbuilt dataset in lavaan, Holzinger-Swineford 1939. It's a dataset with cognitive subtests, and here we want to test whether the latent factor for the visual subtest and the latent factor for the speed subtests really measure something different. So here are the measurement models for the two factors, and we have an error covariance between two items in this case. If we estimate the CFA in order to assess discriminant validity, we should set the factor variances to 1 as an identification method, using this parameter here. Then we can run the CFA. Before we can use the results of the CFA to assess discriminant validity, we have to make sure that we have an acceptable model fit. Here's the model test. It's just significant, but that's almost always the case. CFI 0.976, that's good. SRMR 0.044, that's good. The RMSEA is a little bit too high, but overall I think we have an acceptable model fit, so I think we can use this model to assess discriminant validity. Here's the factor correlation, 0.533. This normally would indicate that we have discriminant validity because it's not extremely high, but we want to have a more rigorous test of this. So we want to have a hypothesis test that we don't have a high factor correlation. For that we can use the function discriminant validity from the SEM tools package. Here the resulting fit object of our CFA. Here the cutoff value and the level for the confidence interval. There are different cutoff values in the literature for the question of whether you have discriminant validity or not. In this tutorial I follow the recommendations by Rönke and Cho. You can find the full reference information in the video description. According to them, if the correlation is significantly smaller than 0.8, you have no problem. If that's not the case, but the correlation is significantly smaller than 0.9, then you have a marginal problem. If that's not the case, but you have a correlation significantly smaller than 1, you have a moderate problem when it comes to discriminant validity. But if the correlation is not significantly smaller than 1, you have a severe problem when it comes to discriminant validity. I start with a cutoff of 0.8. Here we have the results of two different tests of discriminant validity. Here is the correlation. That's the same we found earlier in the output of the CFA. And here is the 95% confidence interval of this correlation. And since the upper limit of this confidence interval is smaller than 0.8, we have shown that we don't have a problem when it comes to discriminant validity in this case. There is a second test that is marginally better, but Rönke and Cho basically recommend just looking at the confidence interval. The second test is the rest of the output. This is a likelihood ratio test. And this test compares two CFA models. The CFA model we estimated earlier compared to a CFA model where the correlation between those two factors was fixed to 0.8. And if this likelihood ratio test is significant, then the correlation is significantly smaller than 0.8, which here is the case. So this is a second way of testing that we have a correlation smaller than 0.80. If this test had not been significant and we wanted to use the likelihood ratio test for assessing discriminant validity, then next we could run the same function with a cutoff of 0.90 to test whether, based on a likelihood ratio test, the correlation between those two constructs is at least significantly lower than 0.90. Here, obviously, because it's smaller than 0.80, it will also be smaller than 0.90, so again, it's significant. But if this had not been significant, then the next step would be to test whether the correlation was at least significantly smaller than 1. Here, of course, significant too. One important additional information, you could have two measures that are negatively related to each other. In that case, the cutoff values change the sign. So then no problem would be a correlation higher than minus 0.80. A marginal problem would be a correlation that is not significantly higher than minus 0.80, but at least significantly higher than minus 0.90, and so on. And in the case of a negative correlation, you would have to look at the lower boundary of the confidence interval. What can you do if your test of discriminant validity fails for the measure you're developing? For that, you will find a couple of suggestions in the article by Rönke and Cho. Thanks for watching and see you in the next video.